Welcome to this explainer. Today, we're mapping out a massive, rapidly accelerating collision. We're looking at the exact intersection where artificial intelligence, enterprise cybersecurity, and global regulation are crashing into each other.
Let's kick things off with a massive wake-up call that happened just recently, the data breach at financial giant Apollo. This whole thing went down between July 6th and July 10th of 2026. Now, in the cybersecurity world, a 4-day window, that's practically the blink of an eye. Yet, it was enough time to completely compromise one of the largest private equity firms on the planet. Before we even get into the crazy advanced AI stuff, we really have to look at the baseline of how these modern breaches actually start.
Because what's really fascinating here is how shockingly low-tech the entry point was. You'd probably picture some sophisticated Matrix-level algorithms smashing through firewalls, right? Well, actually, the reality is way more psychological. The attackers simply use social engineering. They literally posed as IT support, called or messaged employees, tricked them into handing over their credentials, and just walked right through the front door. And the crazy part, this wasn't just an isolated incident. It was part of a much wider, coordinated campaign actively targeting Wall Street. It really just goes to show that no matter how many millions you spend on digital infrastructure, human beings are always going to be the most vulnerable entry point.
And the fallout of that simple human error? It exposed the absolute holy grail of sensitive personal data. We're talking names, dates of birth, contact info, home addresses, and yep, social security numbers. Once that specific combo of data is out in the wild, it spreads like wildfire and gets weaponized for identity theft, financial fraud, you name it. When we talk about these giant enterprise breaches, it's super easy to get lost in all the corporate jargon. But this right here, this is exactly why it matters to you. It's incredibly personal. And as we're about to see, the tools used to exploit these vulnerabilities are getting a massive, unprecedented upgrade.
Section 1. AI Cyber Capabilities. Cheap and powerful.
So, if a simple phone call posing as IT support can bring down a Wall Street giant, what on earth happens when those malicious actors get their hands on autonomous, highly capable AI models that literally never sleep? The whole game shifts from human speed to machine speed. And prepare to be surprised, because this number is our new reality. $295. That's not the cost of some high-end enterprise software license. According to recent benchmarks, it costs only $295 to run 3 full offensive hacking attempts using DeepSeek V4 Pro. To put that into perspective, DeepSeek V4 Pro is currently ranked as the #1 AI cyber model in the world. So for the price of a decent pair of headphones, pretty much anyone can now rent world-class offensive cyber capabilities.
So where does that crazy number even come from? We have to look at the massive Aikido AI model benchmarks. The sheer scale of this testing is just mind-blowing. Researchers threw 11.7 billion tokens across 10 different top-tier AI models. They gave each of those models 3 distinct attempts to hunt down and exploit 32 fresh off-the-shelf vulnerabilities. And they didn't just ask the AI to find old patch bugs. They unleashed them on fresh targets. The results definitively prove that top-tier hacking tools have become astonishingly cheap, highly effective, and widely accessible. The barrier to entry for cybercrime, it has practically vanished.
Section 2. Pausing AI Development. The Corporate Shield.
All right, so with weapons getting that cheap and powerful, the biggest tech companies in the world are frantically pulling up the drawbridges and building massive defensive fortifications. I mean, they know exactly what these AI models can do because they're the ones building them. OpenAI's aggressive new security posture is honestly a masterclass in modern defense. Take their mandatory 2-week pause on AI development to assess risks. In the hyper-competitive tech space, a 2-week pause is basically an eternity, which just shows you how seriously they're taking this. Beyond the pause, they're isolating workloads and networks so a breach in one room doesn't burn down the whole house. Plus, they're running continuous security testing and intense red teaming, which is where their own security experts try to hack their own systems to find the weak spots before the bad guys do.
Section 3. The Zero Data Guarantee.
But here's the thing, securing the network itself just isn't enough anymore. Which brings us to their next massive defensive maneuver. Companies like Apollo need an ironclad guarantee that if they use these frontier AI models, their highly sensitive proprietary info won't end up in the wrong hands or suddenly get spat out to a competitor. So enter zero data retention. To put it simply, it's an absolute rock-solid firewall around your privacy. It guarantees enterprises that their sensitive data is never stored, never reviewed by humans, and most importantly, never used to train future models. It's the ultimate corporate shield, built to restore trust in a world where data leaks have totally shattered it.
When you look under the hood at how this actually works, it's pretty impressive. OpenAI retains absolutely no prompts. Everything sent to the AI is encrypted by the customer's own key, which means OpenAI literally lacks the mathematical ability to unlock it even if they wanted to. The enterprise data is strictly walled off from the model training process, and not even internal security reviewers can peek at the content. Right now, this architecture is being rigorously tested with early customers. It's a fundamental redesign of how data flows between a client and an AI provider, specifically engineered to ensure those Apollo-style breaches just cannot happen through their platform.
Section 4. The global stage. The regulation debate.
Okay, zooming all the way out to the macro level, this frantic defensive scramble has triggered a massive, high-stakes geopolitical tug-of-war over AI regulation. You've got incredibly powerful, cheap cyber weapons on one side and lockdown corporate fortresses on the other. Governments are watching this unfold, and naturally they're rushing to step in. But this regulatory push is facing some incredibly fierce pushback. Critics are sounding the alarm, using this brilliant metaphor of Trojan horse regulation. They're basically saying these policies look like necessary protective safety measures on the outside, but carry hidden, totally destructive economic consequences on the inside once they actually become law.
We really need to look at both sides of this impartially, because the future of the internet essentially hinges on this exact debate. On one side, proponents are urgently demanding strict regulation. They argue it's quite literally the only way to establish guardrails and prevent catastrophic global cyber events. But on the flip side, critics are warning that the cost of complying with these rules will be astronomical. They argue that only massive big tech monopolies will be able to afford the armies of lawyers and compliance teams, which will completely kill off smaller startups. They fear this will tank tech investment, force innovative AI labs to pack up and move outside the US, and ultimately just hand AI supremacy straight to China. Both sides have incredibly compelling, data-driven arguments about the survival of the entire tech ecosystem.
So I want to leave you with this final, provocative thought to chew on as we wrap up this explainer. As AI cyber models become astonishingly cheap and accessible to anyone with Wi-Fi, while at the exact same time global regulations threaten to become intensely strict and expensive for innovators to navigate, who is really winning the digital arms race? Are we actually building a safer digital world, or are we just locking ourselves in a fortress while the threat completely outpaces our ability to adapt? It's a massive puzzle, and understanding the source material we covered today is step one in finding the answer. Thanks so much for joining me, and keep questioning the data.